So now we've looked at fundamental theorem of calculus part 1, where if we have a function of x equal to an integral where x is one of the upper limits, we know that the derivative of the left side would also mean we have to take the derivative of this side as well. And when we take the derivative of that, it comes out to be f of x. So we're going to look at some of those derivative problems here. So this one, you can see they want us to find what is the derivative of this integral, which is a function of t, but we're finding it as x is one of the variables there. So if we apply fundamental theorem of calculus to this, that means taking the derivative of that should result in this same function of secant here, but now instead of a function of t, this ends up being a function of x. And so basically you just end up replacing the t with an x. So that would be the solution to this one. The next one also wants us to find the derivative. It's set up a little bit different where they have a function equal to it, but same thing, if we find the derivative of the left side, that means we're finding the derivative of the right side as well. So there you can see it looks like the last problem we just did where you get that derivative notation in front. So what do we do here? Well, here now, if you notice, our x isn't on the bottom anymore. It's on the top anymore, it's on the bottom. We can remedy that though using some of the integral properties. Remember, if you switch around the two limits, what that results in is the same thing but negative. So we can switch our upper and lower limit around, and that means you're going to get the same value, just opposite. So now this just looks like the problem we did before. We can apply the derivative there, and you're just replacing the t with the x, and you get the same thing, except it's going to be opposite now. So we get the opposite out of e x cubed, and that would be the solution to that one. Okay, next example. Again, it's one of these ones where they're asking us to find the derivative. So if we find the derivative of the left side, that's our derivative of capital F of x. The right side, we're applying fundamental theorem. But what's different here is both of these have x's. Also, one of them has an x squared on there. So one thing we can do if they both have it, what you can think of this as is like you got some graph here, this f of t graph. Let's say x is right here, x squared's over here somewhere. We could pick something else in the middle, say like a c here, and we could think of this as two different integrals. So it'd be like the integral from x to c of this function plus then it would be an integral from c to x squared. So we can still do this problem. Now these look like the ones we just did in the last two problems where one of them is a constant now and not both variables. So if we did this one, the one on the left there, if you change that around, that one's going to be negative now if we replace this. C, so you got this. And this other one, we do have the x on top here. So now let's evaluate these. So if you took the derivative now of the left side, that becomes derivative of f. Here we're just again replacing the x's or the t's with x's. So this would be 5x squared minus 3. And I put this in parentheses because we have this negative we need to bring with. Plus, now this is kind of new on this side. We're still replacing our t here with x squared. But the difference with this one now is this is not just x, it's x squared. So when you have a function within another function, this is a function within this other function that we're trying to find here, that's chain rule. So we're also going to have to multiply this by the derivative of that upper limit. So the derivative of x squared is 2x. So this should give us our total answer here if we simplify this. So if we distribute that negative, um, we get that. On this other side, we got power to a power here. That's going to be 5x to the 6th power. And then next, distribute that 2x. And then finally see if we can simplify any of this. That'd be 10x to the 7th minus 6x. It doesn't appear that there's any like terms, but probably going to see this written in descending order of exponents here. So probably that would be the answer you would see like on an exam. All right, let's have you pause and try this one out and see what you come up with here. All right, let's see. Again, derivative of this side, the derivative of x. If you want to split it up like we did in the last problem, you can. Otherwise, it is basically just using the second part of the fundamental theorem of calculus 2, where it's going to be the one on top minus the one on bottom. But you do have to apply chain rule with this one. So if we replace both these t's with x's here, it'd be e to the x over x times the derivative of x. In this case, derivative of x is just going to end up being 1 here, minus what you get if you do the other one. So e to the square root x over square root x, but times the derivative of square root x. And when we're doing that one, we probably want to think instead of square root x that it's x to the 1/2 power. So what we'll get here is e to the x over x. Derivative of x is just 1 minus e to the square root x over square root x. Derivative of x to the 1/2 would be 1/2 x to the negative 1/2. If we're simplifying this now, that's just e to the x over x. This, if we have these two fractions being multiplied here, we're also going to have this 2 on the bottom from the 1/2. If this gets moved down to the denominator, that's going to be x to the positive 1/2, or again, we could write that back in the radical notation of square root of x. If we simplify those, that would be square root of x times square root of x would be x. And what likely would happen on this one, if this were a test question, is they would combine these into one fraction by getting a common denominator here. So you'd probably see the answer written as 2e to the x minus e to the squared x over 2. So that's probably how you'd see the answer written on this one. All right, one last one here. This one came from an AP type exam where it's multiple choice. Find the derivative of the function. Here you can see it is going to be like one of these chain rule ones now when we're doing the derivative. So if you put sine x in for the t's here, it's going to be sine x squared plus. But then we do have to do chain rule here. So derivative of this inside function of sine x, derivative of sine x is cosine x. So now we got to see which one is the answer. I don't see that this really matches any. Let's see if we can figure something out here. We got 1 minus sine squared on top times this other cosine x that we got from the derivative over this. Well, I still don't see that as one of our answer options over there. If that's the case and you're pretty sure that you've done everything correctly, then what you want to look for next is there any way to simplify. So you're trying to look for those equivalencies. And one thing we see on this one is 1 minus sine squared. We should hopefully notice that that's part of one of those trig identities we got. That Pythagorean one that says sine squared plus cosine squared equals 1. That's from unit circle. So if we just manipulate this a little bit and minus that sine squared to the other side, we can see that 1 minus sine squared is the same as cosine squared. So if that gets replaced, now we got cosine squared x times another cosine x over 1 plus sine of the fourth x. And if you simplify that numerator, it does appear C here is the answer. So sometimes if you're pretty confident you've done everything right, look for ways to simplify and identify the correct answer.